Okay, so these notes are over solving exponential equations and inequalities. What this page is saying is that if your bases are the same, so here if you have b raised to the x power equals b raised to the y power, both of your bases are b, so you can drop the bases and just say that x equals y. So for example, 3 to the x power equals 3 to the fifth, then that's the same thing as x equals 5. So here I have the equation 3 raised to the x equals 9 to the fourth power. Well, we can't apply that property from the last page because our bases aren't both 3. But what I can do is I can get our bases to be the same. So I can rewrite 9 to be 3 squared, and that's raised to the fourth power, and that's equal to 3 to the x power. Well, here when we raise 3 to the second power to the fourth, you multiply those exponents. So this is 3 to the x power equals 3 to the eighth. Now that our bases are the same, we can drop the bases and we just get that x equals 8. My marker's not working very good. So we end up with x equals 8. And if you put in the calculator 3 to the eighth power, you'll get the exact same answer as when you put in 9 to the fourth power. So here I have 2 to the 5x equals 4 to the 2x minus 1. I need my bases to be the same. So I'm going to rewrite 4 to be 2 squared, and that's still raised to the 2x minus 1 power, and that equals 2 to the 5x power. When I raise the power to another power, I multiply, so I'm going to distribute out that 2, so I get 2 to the 5x power equals 2 to the 4x minus 2. Now that my bases are the same, I can drop the bases, so I get that 5x equals 4x minus 2. And I'm going to solve for x now, so I'm going to subtract 4x, and I get that x equals negative 2. I have 4 to the x power equals 64 cubed. So I can rewrite 64 cubed. So 4 to the third power is 64. So I have 4 to the x equals 4 cubed. So I get 4 to the x equals 4 to the ninth. And I can drop my bases and I get that x equals 9. You could also get both of the bases to be 2 if you would like, and say that 4 is 2 squared and 64 is 2 to the sixth power. You'll get the same answer either way. So 3 to the 2x equals 9 to the 5x minus 4. I can rewrite 9 to be 3 squared, and that's raised to the 5x minus 4 power, and that equals 3 to the 2x. So I get 3 to the 2x equals 3 to the 10x minus 8. I can drop my bases now, so I get 2x equals 10x minus 8. I'm going to subtract 10x to solve for x, and I get negative 8x equals negative 8. Divide both sides by negative 8, and I get that x equals 1. Okay, the same rules apply for inequalities. So as long as the bases are the same, you can drop the bases, and your inequality is still going to face the same direction. If we multiply or divide by a negative, we'll flip the direction. But other than that, the same rules are going to apply. So I have 5 raised to the 3 minus 2x power is greater than 1 over 625. Well, I want both of my bases to be 5. So what I can do here is I can rewrite 1 over 625 to be 5 to the negative fourth power, because I'm trying to get 625, and I know it's got to be a negative exponent because it got flipped down to the denominator. So 5 to the negative fourth is the same thing as 1 over 625. And on the left side, I still have 5 to the 3 minus 2x, and my inequality is still saying is greater than 5 to the negative fourth. Now that my bases are the same, I can drop the bases, and I get that 3 minus 2x is greater than negative 4. And I'm going to solve for x. So I'm going to subtract 3, and I get negative 2x is greater than negative 7. I'm going to divide by negative 2, and when I divide by a negative, my inequality flips. So I get that x is less than 7/2. I have 3 to the 4 minus 3x is greater than 1 over 243. So I want my base to be 3. So 3 to the 5th power is 243. So 3 to the negative 5th power will be 1 over 243. So this is 3 to the 4 minus 3x is greater than 3 to the negative 5th. So 4 minus 3x is greater than negative 5. So I can subtract 4, and I get negative 3x is greater than negative 9. And divide by negative 3, and I get that x is less than positive 3. And that is it for solving exponential equations and inequalities.